sure it's there. Yay. Okay. All right. I should be good to go. All right. So 7.4. We are going to talk about logarithms. It says, let b and y be positive numbers. So I need you guys to put a circle around this. This is actually very, very important. If y is positive, that means y has to be greater than 0. The logarithm of y with base b is denoted by, and something, I'm going to rewrite it so you can see me writing it, because I sometimes have students who put it down wrong. The log and the y are on the same line. B is the base. The base is a subscript, so it looks like this. You would read it as the log y base b, like that, okay? And this is hugely important. As students struggle with this initially, I keep taking them right back to this statement. This is called the logarithmic form. The log of y base b equals x. If and only if, that's what IFF stands for. If and only if you take the base to the answer equals the inside of the log. Okay? We're going to do several extra examples of this. Let's look at example 1. It says rewrite the logarithmic form into exponential form or vice versa. So if you look here, the logarithmic form says the log of 8 base 2 equals 3. Exponential form, the base is the base. The answer to the logarithm is the exponent in exponential form, and it equals the inside, like that. Now we're going to go in the reverse direction. If I have exponential form, 4 to the 0 equals 1, in my log, the base is the base of the exponential function. The answer to the log is the exponent, so then the 1 goes inside. So it's log 1 base 4 equals 0 is the same thing as 4 to the 0 equals 1. All right, letter C. If I have log 12 base 12 equals 1, it's the base of the log. The exponent is the answer to the logarithm, equals 12. Letter D. The base is the base of the logarithm. The exponent is the answer to the log. So this is the log of 4 base 1/4 equals -1. What I want you to do is you have a little bit of space beside it. Let's squeeze in a few more examples, okay, just to make sure we're getting this. We'll call it letter D. Oh, E, thank you. E. Okay, so suppose I give you the log 125 base 5 equals 3. Who would like to try to do this in exponential form? Jaslyn, what do you think?
The base is 5, so 5, and then the answer is the exponent, which is 3, and it equals 125.
Good job. So it's 5 to the 3rd power equals 125. All right, let's try another one. All right, log 1/3 base 9 equals -2. All right, who would like to try this one, putting it in exponential form? Noah, what do you think?
9 -2 equals 1/3.
Good. And actually, this should have been -1/2, sorry. No, that was my bad. All right, let's try another one. Let's do the log of 6 base 36 equals 1/2. All right, who wants to try this one? Megan, can you do this one?
Yeah, it would be 36, to the 1/2
Yep.
equals 6.
Good. Okay. All right, so I think we're a little bit more comfortable. Now look at example 2. It's not giving us the answer, but we can actually figure it out. In letter A, it says we want to figure out the log of 64 base 4. And the question you want to ask yourself is, 4 to what power gives me 64? The answer to the logarithm is the exponent. So Hannah, what exponent, when I raise 4 to it, would give me 64?
4.
Not 4.
4 to the third.
4 to the third, so it's a 3. Notice though, the answer, like you don't put x equals or box equals, it's the log of 64 base 4 equals 3, okay, because 4 cubed is 64. Now, in letter B, this one's a little bit tricky because this does not look like a 5 right now, it's a 0.2. But what I know is 0.2 is 2/10, right? But 2/10 can be rewritten as 1 over 5. Alright, so I'm really looking at, so sometimes you have to manipulate what you have to see what it is. So if I have the log of 1/5 base 5, I'm really asking myself, 5 to what power is 1/5? And if you look at our warm-up, you should have, warmed up with this, that when I had 2 to the -1, I have 1/2, right? So this would be -1. Alright, I'm going to give you a head start, and I want you guys to now try C, D, and E on your own. And let's see if you're getting the hang of this. As you're working, this really does emphasize whether you understand exponent properties, rational exponents as well. Alright, letter C. I'm asking myself 1/5 to what power would produce 125? What do you guys think? -3, right? It's not -1/3, okay, because I don't need a cube root. Okay, 1/3 power would be a cube root. A 1/2 power would be a square root. So, and you need a negative because we needed to flip the 1/5, and we needed to then cube it, okay? All right, how about letter D? The log of 6 base 36 means 36 to what power would produce a 6? 1/2, because you want a square root. Remember your exponent properties. A 1/2 power means square root. All right, now letter E. 2 to what power would give you 1? 0. All right, good job on those. Are you starting to get the hang of it? Logarithms are actually very simple once you get the hang of them. All right, we have another group of definitions here. A common logarithm is a logarithm with base 10. So you'll either see a log log base 10 or you'll see the log with nothing. If you see an log with no base, it is assumed base 10. Okay? A natural logarithm is a logarithm with base e. It can be denoted by log base e, but is most often denoted ln. So what I want you to do is I want you to take out your calculators, and I want you to look down the left column. There's an log button and an ln button. So we're going to use both of these. So at this point, eventually we'll get to change a base where you can do different bases on the calculator. But right now, with the calculator, we're only going to do base 10 and base e. So letter A says use your calculator to do log 8. So you press the log with the 8 and press enter. That's it. So it's 0.903. ln, if you do ln 0.3, That's the natural log. Natural log means base e. You've got to remember that. It's negative 1.204 if we round. Okay? All right, now let's look at example 4. Let's see an application here. It says the wind speed s in miles per hour near the center of a tornado can be modeled by s equals 93 log d plus 65. I want to pause right here, though, to point something out to you so there's no misunderstanding or assumptions that are made that aren't true. If they mean for this to be the log of d plus 65, like that the plus 65 is inside the log, they will put a parenthesis around it. If there's no parenthesis, this means just the log of d, that's it, plus a 65, okay? Just want to point that out. All right, where d is the distance in miles that the tornado travels. I want to pause here a moment. There are so many applications for logarithms that I don't think you realize. So you can compute wind speed of a tornado using a logarithm. If you've ever heard of earthquakes that have like a 7.3 on the Richter scale, the Richter scale is based on a logarithmic scale. In science, you have probably talked about pH, where 7 is neither acidic or basic, but is it when you go down to 1 it's basic and 14 is acidic, or do I have it backwards? Have you guys done pH in chemistry?
That's the temperature.
Okay, no.
Maybe later on.
Oh yeah, in chemistry you should cover pH. That's a normal chemistry concept. So anyway, pH is a logarithmic scale. That's where the 1, the 2, the 3, and the 4 are coming from. Let me see what else. Oh, decibels, sound. The intensity of sound, decibels, are a logarithmic scale. It is amazing the different ways you use logarithms, but because of the numbers they're giving you, if you didn't understand that's where they're coming from, and my boys try to make fun of me, and they'll say, Mom, they'll play some, can you hear this? I'm like, no, and they're laughing because they're like, old people can't hear this sound. Only young people's ears can hear this sound. I'm like, okay, I can't hear it. But anyway, when you think about that kind of sound, that the intensity, and like if you go to like a concert, you know how loud that is. That is such a huge range in terms of decibel output. And so that's why they use a logarithmic scale to express that. All right, so back to our problem, example 4. In 1925, a tornado traveled 220 miles through 3 states. Estimate the wind speed near the tornado center. So all we're going to do is we're going to replace the D with 220. And with your calculators out, let me show you how we're going to enter this, okay? Just to make sure we're good to go. I have 93. It's an LOG, so if it's LOG, you use the LOG button. 220, but you have to close the parenthesis. Otherwise, you're going to get a different answer, and it's going to be the wrong answer. So you press enter, and I'm getting 282.8. Let's go ahead and practice writing our answers in complete sentences because that's important. The purpose of mathematics is to be able to communicate what you know. So the wind speed near the tornado center is about, we are approximating it, 282.8 what? What would be our units here for wind speed? It says miles per hour, okay? So remember with word problems, you should write it in a complete sentence for your final answer. But isn't that amazing? Did you know that you could calculate that? And think about those storm chasers that chase tornadoes. Because really, can they be inside the tornado to estimate it? No, but they've come up with a formula where they can figure out, like you'd be dead if you were in 282 miles per hour. Yeah, you would not survive that. Okay, moving on. So what we looked at with our warm-up today is we switched the x and the y, and we looked at what the inverse function looks like. Well, if you have an inverse, do you remember back in the previous chapter that if f and g are inverses, then f of g of x is x, and g of f of x is x. Well, if g of x is the log x base b, and f of x equals b to the x. Let me show you something that's very, very interesting. If I look at the composition, according to the definition of inverses, f of g of x should equal x. But let's look at the composition. This is f of the log of x base b. And if f of x is b to the stuff, this is going to be b to the log of x base b. And that is supposed to equal x. So what it's really saying is if you have the same base and a log, because they're inverses, they cancel each other. They undo each other's operation, and you're left with just what's inside that log in the exponent. So watch letter A here. This is, really, there's log means base 10. So the 10 and the log 10 cancel, and it's just a 4, okay? That's it. Now, if you go to do the other direction, you end up with this one. The log of b to the x base b is x. So they undo each other, and it's just the exponent. So here, what I'm going to do, I have to do a little bit more work than I did in letter A. 25 is 5 squared. I'm going to rewrite 25 as 5 squared. So then this is the log of 5 to the 2x base 5. Because I have a log base 5 and then my exponential is 5, it's just 2 to the x. Now, I want you to put a star next to this one because I'm not going to put this on the test or the next quiz, okay? Because this is really pretty abstract and complicated, and I'm just trying to plant the seeds this year in Algebra 2. We'll go over it again in pre-calc, and then you'll be required to really understand it, but I'm just kind of laying the foundation this year, okay? All right, now, example 6. You're definitely going to need to know how to do this on a quiz. Okay. All right, it says find the inverse of each function. Well, let's write our note to ourselves. To find the inverse, you switch x and y, then solve for new y. So let's do this. If I switch the x and the y, the problem I have is y is the exponent. And something I've seen over the years that is truly goofy is I'll see students who try to divide by 6, okay? And they say, I'm going to write it up here. They say 6 to the y, I'm going to cancel the 6's and that's y. Do you know why that is so goofy? Okay, y is a placeholder for a number, right? So this has to work for a number. If I said I have 6 cubed over 6, and you're saying that that equals a 3, that's ridiculous. 6 cubed over 6 to the first is 6 squared, which is 36. Like, that does not work, okay? So don't try it. And for whatever reason, students like try to come up with these new properties that I'm like, okay, try it with a number. And if it won't work with a number, you can't do it with the letter, because letters are just a placeholder for our numbers. All right, so we appear to be stuck. And if you remember, when we first started this, I said to you, every time students seem confused, I'm going to lead you right back here. So now, my x and my y's are really in a different spot. I have b to the y equals an x, don't I? It's a 6, but I have 6 to the y equals x. I can go from exponential form to logarithmic form. Okay, and watch this. This is the power of a logarithm. That's why they're so helpful. Watch this. This is a log. The base is 6. The answer to a logarithm is the exponent. And so the x goes in the inside. Please, please do not try to memorize log x with base b equals y, putting those x's and y's, because Do you see my x and y's are now in the opposite spots, and then you've learned it by an x and a y. Don't do that. Learn it by the base is the base, the answer to a logarithm is the exponent, okay? You want to keep it like that. Then you're not going to get mixed up. Now, I'm done. That's my inverse. And we might want to just take one little step and write y inverse, okay? All right, now I'm going to do a similar technique here. I'm going to switch the x and the y. And I cannot subtract 3 from both sides because it's inside a logarithm. And I have students who just do the craziest things. And I'm like, yeah, we would do that, but not if you had, 2 times x plus 3. You can't subtract a 3. You have to do the outside. Well, you can't undo an ln. You can't divide by ln. That doesn't even make any sense. So I appear to be stuck. Anytime I get to a place where I think I'm stuck, I can't do anything, I go from exponential form to logarithmic form, or this is logarithmic form, right? I can go to exponential form. What's the base of an ln? E. It's E. ln means base E. We don't write log base E. We just do ln. So watch. The way that you rewrite it is the base to the answer equals the inside. And now I can subtract 3. So my inverse is e to the x minus 3. I'll do a lot more examples tomorrow. We're going to spend 2 days on this lesson. You're going to do the first row on the assignment sheet. But because of time, I need to keep moving. You are encouraged, though, to watch the video again. If you're confused today, watch it again. It will be very, very helpful. You can pause it, rewind it. All right, with a logarithm, recall the inside of a log must be positive. Remember, I had you circle it and said the y, and in that definition, y was the inside. Okay, so a couple things are going to happen here. To find a vertical asymptote, okay, logarithms are the inverse of exponential functions. And what we just quizzed on were the exponential functions that had horizontal asymptotes. So now their inverse has vertical asymptotes. To find a vertical asymptote, you set the inside of the log equal to 0. So in this case, I set x equals 0. There's my vertical asymptote. To find domain of a log, you set the inside of the log strictly greater than 0. Remember, the inside of the log has to be positive. The inside of the log may not be 0, and it may not be negative. So the domain in this one is just x greater than 0. And based on our warm-up, do you see that the log, that's the one that I did in blue, it's all real numbers. Now this is going to make a lovely connection to our exponentials. Do you see the domain and the range are flipped? Do you remember domain of exponential was all real numbers? So the range of its inverse is all real numbers. That's super cool. All right, now the next piece is the table. Today I'm going to show you one way, and tomorrow I'm going to show you a second way. And actually, you really do know the second way. I did it in the warm-up for you. But watch this. I'm trying to look at how do I get some points for the log of x base 3. And I'm going to put some points in here, and it's going to vary for every single one because it depends on your base. You cannot put this in the calculator right now. You don't have enough information yet. Later, I'll give you more information, but for now, it can't go in the calculator. Remember, x has to be positive. So if I start with 1, you're asking yourself, the log of 1 base 3, what exponent does that? 0. Now the next nice number I want to do is a 3, and you'll notice the pattern in a moment. What if I have the log of 3 base 3? What's that? 1. The next nice number is a 9. I'm looking for powers of the base, right? Because what's log 9 base 3? It's 2. What's the next nice number? 27, and the answer's 3. Now you have to be careful with this graph and the table that we're using. I don't see any negative y values, but there are negative y values.
X values.
No, there's no negative x values.
Because you said there's no negative y. You don't see any negative y values.
Yes, and so but there are negative y values. There are no negative x values because look, we said the domain was x greater than 0. Now, I'm not going to go out to 27, guys, but I just was going that far so you could get the hang of this.
She was just saying that there can be y values that are negative.
Does that make sense? Okay. Yeah. So here we go. I have 1, 0, I have 3, 1, and I have 9, 2. Now, what you have to kind of imply with this strategy is that I really could have put a 1/3 in my table, right? If I had 1/3, that'd be a -1. And I could have done 1/9, and so on. Now keep in mind, we have a vertical asymptote. So this is a vertical line that the graph is going to get really close to, but not touch. The second method for doing this is like the warm-up. What you could do, okay, here's a second method for graphing. Is you could switch x and y, then plug in y values first. So like this would be 3 to the y equals x, and do -2, -1, 0, 1, 2, like that. It'll produce, do you understand that this is the inverse? You know, when I've rewritten it that way?